Perfect.
What's the volume of that sphere?
Okay, so volume is equal to 4 over 3 pi r squared.
Is it pi r squared or pi r cubed?
Oh, cubed. It's cubed.
Well, here's the way you can tell,
Yeah.
Dylan, is that
Yeah.
volume is always in cubic whatever. It's always
Mhm.
going to be cubic inches or cubic meters. And the only way you can get that is if you take the linear measurement, which is a radius, and cube it. So
Okay.
it has to be cubed.
Yeah.
Same way with the volume of a cube is
Mhm.
that it's 3 dimensions times each other.
Right.
So
Yeah.
you end up with cubic meters.
Okay.
And that's one way to memorize the volume equation. So what do I substitute here?
Okay, so it'd be 4 over 3 is equal to pi times 12, or r cubed. Oh yeah, 12 cubed. So.
Okay, yeah, that's good enough. We don't need to come up with an answer here.
Okay.
Number 2.
Pi and 12 cubed. Okay. So number 2 would it'd be 13 times 13 times 13.
Good. Number 3.
13 times 13.
Yeah, 13
So,
cubed. Mm-hmm.
okay, yeah. I was just making sure. 97. Let me just write this down real fast. Hold on. Okay. So number 3 we would do, it's around, what does that say? Regular pentagonal prism.
Let's start with the general.
Right. So it would be base times height.
Capital B or small b?
Small b.
Capital B.
Okay.
It's an area.
Okay.
That's what the difference between capital B and small b is. Capital B is an area. Small b is a linear. If I have a rectangle and I say what's the area, it's b times h, but that's a small b.
Right.
Up here, you're talking about the area of the pentagon. The area of the base. So what is the area of the base? Now, in other words, that's the top level general equation, but what's the area of the base? What's the equation?
So the area, so it'd be base times height, or b1 times, no, that's not, that's...
Look at the information they give you. What is that thing called?
Pentagonal prism.
No, this measurement right here, the 6.9 centimeters.
Oh yeah.
What is that?
That's the height.
The height of what? No, the height of the prism.
The height of the
20.
Right. Is 20. Yeah.
What is that 6.9? If you can remember what it is, you'll remember the formula for the area of this pentagon.
It's base times height times height again.
No, it's
so we
the apothem.
Right, twice. The apothem.
It's the apothem.
Oh, that's right.
What 6.9 is.
So you do,
What's the equation that has apothem as part of it?
ASN divided by 2.
There you go.
Perfect. Okay.
So that's our real general equation.
Yeah.
And we have all of this information. So fill in everything.
Okay. So we would do 6.9 times 10 times 7.
How many sides are there in a pentagon prism? What's pentagon?
Oh, 5. 5.
Okay.
Yeah, my bad. My bad.
And then times 20, the height or the thickness of the prism.
Right.
So the whole thing was really knowing that formula right there. Okay? Right. You knew the top one, but you didn't know this one. But if you look at all the dimensions they're giving you, you should be able to figure it out, because there's only one thing that looks like that, and it's an apothem.
Uh-huh.
In other words, it's not a radial line, it's not a complete dimension, it's clearly something unique, and the apothem is the only thing I can think of that looks like that.
Right.
Okay,
Yeah.
number 4.
Okay. So we would do for this one, it'd be base times height divided by 2 for the regular.
Hold on, it's base times height.
Right.
It's not divided by 2. Whenever anything goes to a point, how much do you lose of the volume?
3.
You lose 2/3 of it, which means it's base times height divided by 3.
Right.
For number 4 and also for number 7.
Mm-hmm.
Of course, number 7 is the same thing. It goes to a point.
Yeah, exactly.
Okay. Now give me the secondary. What is capital B in number 4?
Yeah, so it would be 66 is capital B. So volume is equal to...
Hold on.
Yeah.
Capital B is the area of the base. Just like capital B was the area of that pentagon.
Right.
So what's the area, what kind of base is that in number 4?
It's a 90-degree angle.
The triangle.
Right.
The triangle. This was a pentagon. This is a triangle. So what's the area of a triangle?
Base times height divided by 2.
And I'm going to use a little b there because that truly is the linear measurement. Okay, and then that h, I'm going to put a 1 there because that h is not the same as the h inside the parentheses.
Yeah.
Okay, now what is the base and the height of that triangle?
So the base of it would be 88 plus the...
Not plus.
Or just 88.
Uh-huh.
The base.
In other words, the base, the base is not one of these sides here.
Okay.
You have to call the base the side that is perpendicular to the 21 inches that they're showing.
Yeah.
21 inches is the height.
Okay.
Of the triangle.
Okay.
And then what's the height of the pyramid?
66.
Okay.
Cool.
So, again, you had a little bit of trouble translating. In other words, it's not going to be helpful to you if you know that, if you don't know the formula for the area of the base.
Yeah.
Both problems, you've gotten tripped up on this step right here.
Okay.
On figuring out what the area of that pentagon was and also figuring out the area of that triangle.
Okay.
All right.
Okay.
Now, number 5.
Alright.
Triangular prism.
Mm-hmm.
So the volume is?
Okay, so volume would be base times height divided by 3.
No divided by 3 here. This is not going to a point.
That's right, yeah.
This is not a prism. Number 4 is not a prism, nor is number 7. There are no two opposite, parallel, equal bases in 4 and 7. But number 5 there is. In number 5, this triangle is at both ends of that prism.
Right.
So that is a prism, so we need the area of that triangle.
Mm-hmm. Okay. So the base would be 8, and then, oh yeah, we're doing this. So it'd be, yeah, so it'd just be base times height divided by 2.
Okay.
For the triangle.
So base times height divided by 2, and that's the area of the triangle, and we're multiplying it by the height of the prism.
Yeah.
And now we got to do a little bit more work here, because what's the base?
The base is 17.
Not really. I mean, you can call any side of a triangle the base, but you have to be able to figure out how to get its height. And you can't do it if you use 17 as the base, because we don't know the distance from that line to that vertex. That would be its height, but we have no way of figuring that out. However, we've got a right triangle, so if I use that as the base, then that would be the height, or I can call that the base and that the height. But I got to figure out those two dimensions. What's the dimension right here?
The dimension, where were you pointing them at?
Right here.
Yeah.
Here, let me. 8. Okay. That's 8. That's 17. We need this one right there. Can you see where I'm pointing?
Yeah. Okay. Would you just subtract 17 from 8 to get that side?
No. What kind of triangle is that?
That's a right triangle, so we would use the Pythagorean Theorem.
Okay.
Yeah. So it'd be 17 squared minus 8 squared is equal to x squared.
Good.
Cool.
That also is a perfect Pythagorean triangle. It's an 8, 15, 17.
Uh-huh.
So that distance is 15.
Okay.
Okay, so now fill in everything.
Okay. So since x is 15, okay. So it would be the base. Would you add 15 and then 8 together to get the whole base at the bottom?
No, it's base times height.
Okay. So it'd be 8 times 14.
8 times 15. In other words, this is the area of the base. Okay? So let's isolate our thinking to just this triangle on top.
Okay.
Okay? That 14 doesn't have anything to do with that triangle on top.
Okay.
What we need from this triangle on top is these two dimensions. We just figured them out. They were 8 and 15.
Right.
So that's little b and little h is 8 and 15.
Okay. That makes sense.
Times the thickness of the pyramid is 14.
Exactly, yeah.
Now, number 5 is exactly the same as number 4, except for one key difference. Number 4 goes to a point. So it's this formula divided by 3 for number 4, whereas for number 5 it's a prism, so it's just the base times the height. But once you get beyond that first formula, everything else was the same. In fact, look, that's a right triangle. That's a right triangle.
Yeah.
So we're going to do these problems exactly the same, only this one, the volume is going to be that base times the height divided by 3. This one's just going to be that base times the height.
Okay.
Okay, and then number 6, they say it's a prism. So therefore, which two is the base?
Right, so we would do base 1 plus base 2 divided by 2 times the height to get the volume there.
Okay, so we're going to say it's the area of the base times the height. Every prism starts off that way.
Right.
And then the area is the trapezoid, is one of the bases. There's the backside of the trapezoid there, and so these two are equal and parallel.
Yeah.
And you're correct that the area of the base is base 1 plus base 2 divided by 2 times h1 times h2.
Okay.
How does your teacher refer to these h's separately?
I think he just did like what you're doing, like h1 and h2.
Okay. I've never added the 1 before. I've always used the 1, but never anything on that. But I like this better, h1 and
yeah, me too.
So now here's the problem. We draw that trapezoid.
Mm-hmm.
They do tell us that's an isosceles trapezoid. And we
Right.
know what base 1 is, and we know what base 2 is, but we don't know this.
Yeah.
But we know that this is 13.
Right, which is...
We have to solve for H1.
Okay.
What's this side over here?
That side would be 10.
Well, the bottom base is 10 more than the top base, but it's equally divided.
Right. So that'd be 5.
Okay.
Okay.
Now, what kind of triangle is that? That has the short side and 13 as a hypotenuse.
That's a 12, 13, 15, no, that's 7.
Yep. No, you're right. It's a 5,
12,
12, 13. So we don't have to do the math if we recognize that.
Right.
So now we have everything.
Yeah.
So plug it in. Go ahead.
Okay. So it would be the base, so 33. Oh, yeah, we're still trying to figure it. Yeah. So 33 plus 23 times 12 times 13.
What's the thickness of the prism?
44.
In other words, this picture here is only the face of that prism.
Right.
The 13 is not a factor, other than helping us figure out what the height of the trapezoid was. But what's the thickness of the prism?
44.
Okay, and that's H2.
Cool.
And there we have all those numbers there. So.
Cool.
All right. And number 7.
Okay.
What's volume equal?
So again, it'd be base times height. And then for that, it would be...
That's a prism is base times height. This
right.
is not a prism. 7.
It's a cone, so it'd be divided by 3.
Okay.
Yeah.
And the area of the base, what's the formula for that?
So the formula of the base would be pi times radius squared.
Okay. Now, how are we going to get the radius? Because they don't give it.
So we would just put in the information we do know, and then just use algebra to isolate the variable.
Be more specific. How are you going to get that radius?
So we would do pi times height, divide that by 3, and then set that equal to radius.
No, in other words, for us to calculate the volume of that cone, we're going to need the radius and the height. Well, the height is 60.
Right.
So we have the height.
We don't
have a radius. How do we get the radius? The distance from here to here.
Find the diameter, or the square, or not the diameter, the square root of...
diameter, but you can find the radius.
Right.
The secret is to draw a triangle. Draw a triangle that represents the side view of that.
Right.
This is
and it's a right triangle, so we could use the Pythagorean Theorem to find.
61, and what is that measurement? Can't think of what this... this is a perfect one also.
Yeah.
I don't know what this is. I'm tempted to say 7, but do you have your calculator? Do 61 squared minus 60 squared, take the square root of that.
Okay. Minus 3,600.
Doesn't actually have to be a perfect number. In fact, it almost makes more sense if it's not.
Right, it's 11.
It is 11, okay.
Yeah.
The reason I said it would be okay if it turned out to be like square root of 11, because we really don't need r, we need r squared.
Exactly, yeah.
So,
Yeah.
But anyway, now we have everything. 11 is
Cool.
the radius. So it's
Pi
121 pi times 60, all divided by 3.
Right.
Okay.
Cool. Awesome.
Let's do 9 next.
Okay.
And then we'll do 8. I think 9's a little harder. 8 is what? It's a prism. It's another prism.
Right. We would use AP divided by 2, right, for this one, because it gives us the perimeter. Yeah.
Yes, exactly.
Okay.
Because they don't give you the side length. We know the number of sides, but they don't tell us a side length. So we would have to use, instead of this, we would use this.
Right.
Okay.
Okay.
Number 9.
Alright. So for number 9, we would do, so you have to set 2 equations for this one, right?
Well, you need to break this figure up into 2 things. We have a cylinder and we have a cone.
Okay.
Okay. However, I'm looking at it and I don't see the thing that we need the most.
Yeah.
More information that I'm not seeing? Do we have the radius?
Oh, we don't have the radius, no.
There's no way to get it.
No.
Or is there? Let's see. The height of the cylinder tells us nothing, because the cylinder could be 3 times that way and it would still be the same picture on top.
Yeah.
So the total height, we do have a way of getting it.
Okay.
Notice what the height of the cone is.
We could use the Pythagorean Theorem to find the radius.
Yes, the same exact way we found the radius on number 7. We're going to find the radius here.
Yeah, exactly.
In other words, I'm going to draw the triangle like this.
Right.
And this distance is what?
20.
Good. And this distance is 25. And that looks like a 3, 4, 5 triangle.
It does, yeah.
So this must be 15.
Yep.
Which that'd be 3, 4, 5. Okay, so what's the volume of the cone? In other words, the volume of this thing is the volume of the cone plus the volume of the cylinder.
Right. So we would do...
That's H2. And these capital B's are the same. Right? Yeah. In other words, they both are the area of that base right there.
Exactly. So for this one, you would do pi times radius squared times height divided by 3, right?
Okay, so that's pi times 15 squared times 20 divided by 3 plus what?
Plus...
For the cylinder.
Right. So it would be plus the base, which is... Would it be 30 for the base?
It's the same. It's pi 15 squared.
Okay.
It's pi r squared, and it's the same radius. That cylinder has the same radius as the cone does.
Right.
Okay. And the H2 is 44.
Right.
So that's a number, and that's a number. Add them together, you get your other.
Perfect.
And yeah, real quickly, let's just give the formula on number 8. It's capital B times the thickness. And
for number 8.
Formula for capital B again?
For number 8, right?
Right.
Okay, so it would be the apothem, which is 22.5.
Let's just lay it out. Spell.
Okay.
Then we'll fill it in.
Okay, so it'd be AP divided by 2.
Times height, okay, so 22.5 times
Yep.
156, that's the perimeter, divided by 2, and the thickness is 78.
Yeah.
I tell you what, you sure given me some good review material for geometry.
For sure. He's a good teacher. I like him a lot.
I'm putting it in my database so that next year, because a couple weeks ago I was having a hard time getting anybody to send me good review stuff. The teachers weren't giving it out to you yet.
Right.
And I was in need of it, but I won't be in the future. I'll have all these good problems to look at.
For sure. Yeah, these are really good problems.
Yeah, they are.
Yeah. And I guess, like, I was talking to some of my friends that took the final already, and they said there's just a lot of what we've been doing, like a lot of equations. And
oh, yeah. No, I don't doubt that most of your final will look a lot like this page.
For sure, yeah.
So.
And it's really cool, too, because I did a ton of extra credit to add on to my final. So I get 35 points extra credit added to my final.
Oh, cool.
Which is a huge help. So,
yeah.
Yeah. So if I get like a 90%, I get 125% on it.
Wow.
So that'd be
terrific.
Yeah. Yeah, definitely.
All right.
So.
Well, listen, good luck on your final.
Yeah,
and,
thank you.
Good luck on your summer. Hope you have a fun summer. It sounds like you're going to. You're going to get
for sure.
baseball, huh?
46 games, yeah. Wow. Can't wait. I can, if you want, I can text you our schedule, and if it's somewhere in town,
sure,
you'd be more than welcome to come. Yeah.
I don't have a lot to do in the summer. I might be able to find some time, get over there and watch a game. It'd be fun.
Definitely. That'd be awesome, yeah. Awesome.
Okay.
All right.
Well,
perfect.
I will maybe talk to you next fall.
That sounds good.
Or maybe
all right.
summer. All right, Jeff.
Yeah, or maybe sooner.
Have a good one.
Thanks, Mr. Cowan. I'll talk to you later.
Bye-bye.